starts there.
Right.
Anyway, so we're talking about law of sines. So, if we have a triangle, an oblique triangle, that looks like this. Let's say I have that angle is 74 degrees, and this angle here is 61 degrees, and this side right here is 18 millimeters. Now I'm going to label everything. From there, what do I do to solve this triangle? When I'm asking you to solve a triangle, I'm asking you basically just to find all of the missing pieces of that triangle. There's one piece we can, now remember, to use the law of sines, what must we have?
One side.
We must have a side and the opposing angle, the opposite angle. In this case, we have a side right here. Do we have its opposite angle? We can find it really quickly. Anytime we have two angles and one side, we can solve it using the law of sines. How do we find this angle? 180 minus 74 minus 61 is 45 degrees. What do we do from there? (18 over the sine of 45 degrees) equals, which side do we want to find first? Let's do side A. Where does the A go? Over sine of 61 degrees. So we will cross multiply. 18 times sine of 61 divided by sine of 45. Giving us 22.26 millimeters. That goes here. Now, before we keep going, does this make sense? Does that 22.26 make sense? Yes, 61 is bigger than 45. 22.26 is bigger than 18. So it sort of makes sense. What do we know about side C in relation to those other two? It's going to be a little bit bigger yet, right? So 18 over the sine of 45 still holds. It's going to equal C over the sine of 74. So we should cross multiply and divide again. 18 times sine of 74 divided by sine of 45. Equals 24.47. So yes, it is slightly bigger yet. And we've solved that triangle. We now have all 6 parts, all 3 angles, all 3 sides. Well, that was the case where we were given 2 angles and a side, and that was always a relatively simple case. What if we are given 2 sides and an angle? Well, let's say that this angle here is 67 degrees. So that's 27 millimeters, and this is 24 millimeters. If I'm given 2 sides and 1 angle, there is a chance that I can't use the law of sines. Can I use the law of sines here? Yes, because I have a side and an angle opposite it. Or the angle I have the side opposite it, if you want to look at it that way. Now, it's also important that this one, the opposite side, or the side that is opposite the angle, is the longer of the 2 sides. What that means is there is only one triangle that can be formed here. Because, if you think about it, this side being 24, there's no way that that 27 could be tucked in like this. It has to go out this way. There's no room for it to come in here. Does that make sense? If this side were shorter than the other side, that's where we have that possibility. There's two possible triangles we could make. And we have to use the picture to figure out which one it is. So anyway, over here, we have 27 over the sine of 67 degrees. Equals 24 is the only other piece of information we have. That's going to go over sine of angle B. So here, remember, we're going to have a two-step process. We're going to do a cross multiply and divide yet. Sine of 67 times 24 divided by 27 gives 0.8182. But that's the sine of our angle. To get the angle, we do inverse sine. So second sine, second answer, 54.91 degrees. So that was this one here. Now we can find this angle here by subtracting from 180. What does that end up being? 68.09 or something like that? 58.09, thank you. So now that we have that as 58.09, we know that this side is going to be somewhere between 24 and 27, because that angle is between the 54 and the 67. So we're going to go back to the 27 over sine of 67. Remember, we always go back to information that's given to us whenever we can. Then we've got C over the sine of 58.09 degrees. So again, we'll cross multiply and divide. 27 times sine of 58.09. Divided by sine of 67. 24.90 degrees, or 24.90 millimeters. Not so bad. Remember, though, there was another case and let's say that this here is 29 degrees. This over here, we're going to call it 18 millimeters, and this will be 20 millimeters. When we go about solving this one, what are we going to have to remember? Angle B is not acute. Angle B is obtuse, which means not adding onto it, but taking its supplement, right? So we have 18 over the sine of 29 degrees equals 20 over the sine of angle B. We'll cross multiply and divide. Sine of 29 times 20 divided by 18 is 0.5387. Do an inverse sine, second answer. 32.59 degrees is not our answer, though. We need to 180 minus that for 147.41 degrees. Make sense? Okay. Well, now we're going to look at a final possibility. I'm going to trust from here you guys can subtract to get the other angle and then do what you need to get that third side using the law of sines. Here, Can we use the law of sines? Why not? Perfect. We only have one angle, and the side opposite that angle is not known. It's the other two sides. So in this case, we have two sides, and we have the angle in between them. It's called the included angle. Law of sines doesn't work here because we have to have an angle in its opposite side. So in this situation, we're going to use the law of cosines. The law of cosines starts out looking very familiar. Now, I labeled this, and you saw me erase this and relabel it. I labeled it in a very specific way because the form of the law of cosines that I have memorized, the angle that's in between the two sides is angle C. The reason for that is because the law of cosines actually is tied in very close to the Pythagorean theorem. It's actually called the generalized Pythagorean theorem. And it starts out looking exactly like it. C squared is equal to A squared plus B squared. Look familiar so far? But because this angle C here is not a right angle, there's a correction factor. And that correction factor is minus 2 times A times B times the cosine of angle C. Well, let's see how this actually works out. So what I'm actually finding here is the length of that side, side C. C squared is going to equal A is 0.52 squared plus B is 0.588 squared minus 2 times 0.52 times 0.588 times the cosine of 81 degrees. Now, if I'm punching this in the calculator, just like we did with the Pythagorean theorem, I'm going to forget about this squared. I'm just going to put a square root over this. Makes sense? So to punch this in the calculator, I'm going to do this. Second square root 0.52 squared plus 0.588 squared minus 2 times 0.52 times 0.588 times the cosine of 81 degrees. Now, some of your calculators, you may have to close the parentheses twice here. Close it once for the end of the cosine and close it a second time for the end of your square root. So make sure you're keeping track of that. I hit equals, I get 0.721. Side C up here is 0.721 inches. What'd you guys get?
I don't know, I was trying to write down the formula.
Got that? As long as Jared concurs, I'm okay with it. Okay, so now that we have that, I wish I could talk. Now that we have that, we have an angle on its opposite side. So we can do 0.721 over the sine of 81 equals point. Now, here's where, remember I said something about you want to do the smaller angle first? How do I know which angle's smaller? The shorter side, right? Now, in this case, it really doesn't matter because what's the longest side of this triangle? It's this one. So I know that 81 and 81 degrees is the largest angle. So I know that both of these are acute. But the reason I usually do the smaller side first is, remember, law of sines will always give you an acute angle. Well, that largest side, you don't know whether its opposite angle is acute or it might be obtuse. So I'll do an example of that here in just a minute. God, I wish the clocks would work. It keeps freaking me out. I look up and it's saying 7:25. No, these are on a central timing system. So something's just kicked off on them. So it's sine of angle A. So we're going to cross multiply and divide here. Sine of 81 times 0.52 divided by 0.721 is 0.7123. Do the inverse sine, second answer. 45.43 degrees. And then this one we'll find by just subtracting from 180, which I'm not going to bother with right now. It's like 53.57 or something like that. So looking at something like this. I'm going to label it again. I'm going to label this C. If you're running into a problem where they already have the angles labeled for you, I always relabel them so that C is my angle in between. Just because it's just easier for me to think that way. Because that's where the formula is set at. Just make sure you adjust everything back around later so you got the answers in the right place. So, little c squared is going to equal what?
A squared plus B squared. Subtract
2 times A times perfect. So again, the way I'm going to punch this in my calculator is the square root of 19 squared. Oops, come on. Plus 25 squared minus 2 times 19 times 25 times the cosine of 38 degrees. Again, make sure you close your parentheses all enough. And I get 15.41 millimeters. Now, I have the 15.41 over the sine of 38 degrees. Which side do I want to use next, the 19 or the 25? 19. Because I don't want to get into the largest angle. I want to use the smaller of the two angles. So that's going to be over the sine of A. Cross multiply and divide. So it's going to be sine of 38 times 19 divided by 15.41. Gives us 0.7591. Inverse sine gives us 49.38 degrees. So we add those all up, we get 87.38 degrees, which means this is 92.62 degrees. It's slightly obtuse, but you really couldn't tell that from the picture. So that's where you want to find the smaller angle first. When you subtract from 180, it's always going to give you the right angle. It doesn't matter what's obtuse or acute. You don't have to worry about that part. Any questions? I'm going to have you guys try one here quick. Come on. Solve that triangle. Find the missing pieces.
Wouldn't that be weird if you saw
So-
that happen? Like, would that kind of fuck with you a little? Like, what's going on?
What we have, a is going to equal the square root of 20 squared plus 31 squared minus 2 times 20 times 31 times the cosine of 41 degrees. Now notice I managed to switch the variables around. If you wanted to redo them to make this angle C so it's easier to put in the formula, that's fine.
Yeah, but I mean, you could just put the formula in them.
Yeah. If you just put the numbers in, it's not such a big deal. We get that A is 20.62. Is that what you had, Cody?
Yeah, I got
You don't sound sure.
619.
That works. And once you have that, of course, you guys all know how to find the other angles from there. Which angle are we going to find first, C or B? Say B, because it's across from the smaller side.
Say B.
How about this one here? What's different about this one?
No angles.
No angles. Does that mean we're screwed? No, it does not. I'm going to pick the angle. Actually, it doesn't matter here. I could pick the angle across from the largest side if I wanted to because we're using the law of cosines. I know 48 squared equals 32 squared plus 40 squared minus 2 times 32 times 40 times the cosine of angle C. So I can now solve this for the cosine of C and do an inverse cosine. Or I could rewrite the whole thing like this. Cosine of C equals 48 squared minus 32 squared minus 40 squared divided by negative 2 times 32 times 40. So what I'm going to punch in my calculator, I have to use some parentheses. 48 squared minus 32 squared minus 40 squared. Now I'm going to close the parentheses. Oops, helps if I put the 40 on there. So divided by parentheses. Make sure you use the negative and not a subtraction symbol. Negative 2 times 32 times 40, close my parentheses, equals 0.125. So cosine of C is 0.125. So inverse cosine, 82.82 degrees. That was angle C right here. Now that we have that, we have a side and its opposite angle. We'll go over that strategy, looking for the missing angle, more tomorrow. For right now, I believe your packet has page 382 through 385, 18 through 42, actually I should say 19 through 41, the odds. Or now you're going to use the law of cosines instead of just the law of sines.